lecturer and a pure mathematician at JCU, and I'm here today to tell you about the secrets of networks. So you may have already heard from my accent that I'm British. I was born in Inch, and like some kind of combative alcoholic wannabe vet, I spent much of my childhood in battle, glass and cows. But most people seem far more interested to learn that my dad came from the quaint little English village of, and this is really true, my dad came from the village of Fingering Hoe. Yep, Fingering Hoe. It's got to affect you. My research is abstract nonsense. That's not classic British self-deprecation. That is, well, abstract nonsense is a genuine, legitimate term for the field of maths that I work in. And it's pretty accurate, as any of my students will confirm. So I love shapes and patterns and the way that things fit together. And I love these things so much that I actually married my husband because of the shapes we make when we fit together. No. Get your minds out of the toilet. I'm talking about sex. Though, that tiling is quite nice. So, abstract nonsense, which is better known as category theory, studies how stuff connects together to make new stuff. And networks are just collections of things connected together, like food webs or river networks, or the paralyzing interdependencies of the items on my to-do list. And it's actually only quite recently that mathematicians have started to use abstract nonsense, remember that's the study of connected things, to study networks. Connected things. Go team. So, since everything connects to something, networks are everywhere. And some networks are quite simple. Your family tree, for example, is probably pretty straightforward, unless you're royal. So many cousins, and yet at the same time, so few cousins. But I'm interested in complex networks. So usually calling a network complex means that we don't actually understand it. And that's generally because, sorry, I'm behind. There's a complicated royal family tree. Calling a network complex means we usually don't understand it, and that's generally because complex networks are very, very big. Like, for example, the network of neurons in your head, or a social network. Although I'm a pure mathematician, so my social network is not very complicated. So I study the shapes and patterns hidden inside complex networks. And why is this important? Well, networks aren't just everywhere, they're also pretty influential. And understanding them better could help us democratize AI, or better model connected vulnerable ecosystems, or track and trace online misinformation faster than creepy old Uncle Elon could spread it. So let's get rid of him quickly. But you know, what is this actually all about? Like, what am I saying? I said that abstract nonsense is the abstract study of connected things. What does that even mean? What's abstraction? Well, we all do abstraction all the time. It gives us a way of deciding what information we find important and what to throw away. For example, a bee cares about the sweetness of the nectar of these flowers. I'm more interested in the colours and the symmetries. My dog just uses her nose to tell whether she's going to eat each of these flowers or piss on it. Bobcatter doesn't have time for any of it. Abstraction gives us a way of classifying things, right? It gives us a way of telling whether things are kind of the same or when they are fundamentally different. Like, one of these things is different from the others. One of these things is a different shape. And there's at least one fundamental sense in which these two things are the same. And while other scientists may be interested in more concrete properties, more tangible things like pH or whether something is a mammal, mathematicians, kind of a bit more whimsical or poetic, kind of vibey, I suppose. Actually, you may be surprised to learn that there's quite a long history of maths and use of psychedelics, which may change the way you think of your high school maths teacher. This, by the way, is how AI thinks of your high school maths teacher, unsurprisingly. So this is when it gets kind of weird, because pure mathematicians study abstract properties without necessarily connecting them back to the world. And to study those abstract properties, we abstract some more. And then we abstract some more, and some more, and some more. And we may forget about the real world altogether. And yes, this is definitely escapism. But that doesn't mean that pure mathematics is pointless. Because these abstract ideas can sometimes give us new ways of looking at and understanding the world. You can think of it a bit like Google Earth, or climbing a very, very tall ladder to get a better view. As you climb higher up the ladder, you see fewer details, but you do see more stuff, and you see more about how that stuff fits together. So you get a much bigger picture. And that information is useful for understanding the whole system, even when you come back down to the ground. Yes, this is how I dress for work. It is a very, very glamorous profession. So this idea of zooming in and out is also really important for understanding networks, because many of the networks we're interested in are so big that we need to understand them at different scales. For example, when I was a PhD student, I was working for weirdo scientists who were trying to build a human brain by piecing together individual neurons. On a computer, they were high-tech Frankensteins, but this is a massive task. There are approximately 86 billion neurons in your brain, and everyone's head is wired differently. So, if you're building this thing, how can you tell that you're on the right track? Do you have ideas as you're going along, or do you have to wait until the whole thing is finished for the network to display the universally accepted scientifically agreed symbol of human consciousness, a giant willy? I mean, are you like, I don't know if that's a brain, is that a brain? Not sure. Or, oh, I made a frightened mouse. Or, human, nailed it. By the way, the willy thing is absolutely true. In the 80s, a computer scientist programmed a chatbot that fooled people, and I'm guessing they were all men. So a chatbot that fooled men into thinking that it was human precisely because of all its vulgar dick jokes. So how do we, to build a system, a complex system that is capable of pleasure in juvenile humour, we need to be able to understand the patterns in which we need to connect the very smallest pieces, and then how we need to connect those slightly bigger pieces, and so on and so on and so on. And these questions of scale arise in all big, complicated, connected systems. For example, how do you manage individual behaviour to ensure that the global impact of COVID is minimised? How do you identify which lines of some giant code contain a virus? And when the cleanup begins after a cyclone, how does the government know which butterfly to arrest? I'll give you a moment. It's all right. So to answer these questions, we have to be able to recognize signs that can tell us how we can relate patterns that we see at different scales together. This is not so straightforward. Most interesting networks contain feedback loops, and loops are a mixy bit of magic that make infinity from something finite. For example, if you try to race 500 kilometers along a straight 2.9k stretch of road, you won't get very far, just under 3 kilometers. But if you bend those 2.9 kilometers around into a loop, just like the V8 track outside here, then you can keep going round and round and round, just driving forever on a road to nowhere. And loops in networks enable AI to learn. Climate systems to self-regulate for now, and me to lay awake endlessly thinking about the perfect anxiety joke for this set. So my work tries to build abstract nonsense to zoom in and out of complex systems that have loops. And this won't yet tell us how misinformation spreads through Twitter, or whether a slice of brain comes from a Pisces. But it is a small step to understanding, and therefore being in a position to solve some of the greatest challenges in our world, and thereby help all of us to navigate this complex, tangled, loopy web of life. You've been a fantastic audience. Thank you very much.